Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in my software design series. In this lesson, we're going to pick up where we left off and start the implementation of our component pattern. So this will be the first part of the implementation. We'll get something that's working and see how to work with components. So if you haven't seen the previous videos, make sure you check those out in the description below, but otherwise, let's go ahead and move forward here. So as a brief recap, we've been talking about the component pattern, which again is this idea that allows us to basically have a vector of components within some object. That way you can dynamically add or remove them. Now there were some design decisions that we had to make, meaning how many types of components, or if we could have just one unique of each type of component that we add, that you can play around with in your implementation. But let's go ahead and march forward with the implementation that we provided here. So again, the basic idea was to have some base class for a component here, and then inherit from any number of components that you have. So texture components in a gaming example, you might have transform components or whatever you might decide here. And again, this is sort of up to your design, what your domain is. Again, I'm going to give this in the context of a gaming example if you've been following this series. But again, those are the things that you might want to think about, what types of components you have. And if all the components are added to one vector, or maybe you have some by default in every object, again, those are different things that you can play around with. So anyways, we discussed about some different strategies, and you did an exercise last time on how to choose which components to add here. I'll move out of the way here so you can see the full slides. And then here were the things that we wrestled with a little bit, or rather thought about, meaning how do we add the components? Do we add them at a specific index? Maybe we have an enumeration of them. And that was a brief exercise that I asked you to pause the video and think about, and maybe you're still thinking about, so you're welcome to do that. The reality is, once you implement the component pattern a few times, you'll come up with different design decisions, again, to meet the needs of your application. So anyways, let's go ahead, and I'm going to pause it somewhere around here. And this is the implementation that we're going to want to build from scratch. So we have some sort of game object, that's the base type here, and an ability to add components and also retrieve those components as well. And we'll probably have something like this enum class here to determine which components that we're trying to access or insert, and then a way to get the component based off of that component type here. Again, we'll just go with one component for simplicity, but again, you might have a get components plural function to get all the texture components if you want to have multiple objects sharing those components. So anyways, folks, with that said, let's go ahead and begin our implementation here. I'll go ahead and open up a blank coding window. I'm going to bring myself back here so the font's just a little bit bigger. And let's go ahead and just create a main here. And again, we're going to do this in C++, as that's what the series is about here, but you could probably refactor this and do it in any other language that you like as well. So anyways, let's go ahead and start here with some struct here for a game object. Again, that's going to be our base class here. I'm going to avoid for now having some of the things, like for instance, you might want to have a constructor and a constructor that takes in some default components. We're just going to ignore that for now and just have our game object as shown here. So what I'm going to go ahead and do here is start off by creating some sort of structure to hold our different components. So again, I'm going to use a map here. So let's include map here. And again, this map is an ordered data structure. So again, you can think about if your components have to be ordered or not. Again, it just gives things a little bit more of a determinism. But again, there is a cost of map versus unordered map. So check out my other videos in the C++ programming series if you don't know about those data structures. And basically what I want for the key is going to be the component type, and then I'm going to take in a component as well here. So let's go ahead and just call this components. Okay, so component, again, is going to be our base class or interface. In fact, I'll do a little bit better than what I showed last time and put an I in front of it, because that's just a little bit cleaner here. So let's create that component interface, and this is going to be our interface here. And again, you can enforce whatever you want for these components here. In fact, we should probably always have, for instance, and I'm going to make this a virtual void function for update. And this is our function that must be implemented. So must be implemented. Okay, so that's the basic idea there. So let's get this ready to compile. And I'll just go ahead and output this, and we'll run it here. Okay. Okay, so let's add the component type. That's what it's complaining about here. And that's going to be our enumeration for the different types of components. Okay, now I'm going to use an enum class because it's a little bit more type safe versus just an enum, which is just an integer. Again, that way it'll force us to use the scope here for the I'm just going to call, again, component type here, in which we'll have things like texture, maybe a collision box, maybe a position, just to give us a few interesting components here. Okay, so let's see. That should resolve our issues there. Again, if I just use an enum, then my map is just taking in a plain old integer, and then it is possible for the user to do something weird. Instead, I want them to type out component type : : all capital letters texture. Okay, so let's just really quickly create structs for our texture component, which is going to inherit from I component. And again, if we try to build this, we should get an error. Oops, let me make sure I save this here. And, well, I guess it's not going to error out until we actually do something, but we have to implement this update here. In fact, let's go ahead and see if we can, let's crash this here. Interesting that GCC doesn't catch that here. There we go. If we actually instantiate this, so maybe it's optimizing a little bit and just not generating that code. But anyways, this is the point of making this virtual void. Again, if you're not familiar with that in C++, that is basically, this is our way of creating an abstract class or an interface, which are in some other languages. But this is, again, saying for this virtual function, we must implement it, okay, if we set it equal to 0 here. Okay, so that's the idea here. And then we'll have whatever we need to do for our texture component. Let's go ahead and fix that here. And I'm just going to leave that empty for now, but now that works here. Okay, so that's the basic idea here. Okay, and let's do that for a few other components here. Our texture component. Let's create a collision component and a position component here. Okay, so reasonable enough here. Okay, so we've got our different components and our interface. Okay, now let me go ahead and just hide these for now. Just because they're not as important here. And then we'll go ahead and start working on our game object. Now, for our game object, again, the idea is going to be to loop through and just update the components. So everything that is in this map and run their update function here. Okay, so let's go ahead and for our game object now, we'll go ahead and implement update. And basically what I want to do here is just a range-based for loop. So auto, and this is the key and the value here, so the key from the map and the value. And again, this is some, this is just some C++ stuff, but this allows me in this range-based loop here to look through my components and immediately retrieve the key and the value here. Okay, so basically what I want to do here is take a look at my components, whatever the key is that I'm getting back from this structured binding, okay, and then call the update function on it. Okay, so I'm retrieving the value here, which is this I component pointer, and that's why I'm dereferencing it and then calling update. Okay, so that's the idea. So if I open this up here, oops. Basically, again, I'm just calling this update function for each of the appropriate components. Okay, so hopefully that makes sense. In fact, I'll leave one of those open for now just so you can see. Okay. All right, so that's it for update. So if we want, we can go ahead and create a game object. And again, let's call it something like Mario. And then we could call update on it. And this should be working. Okay, so it appears to be working. Now, we haven't added anything to this map, so it's not doing anything interesting, but it'll loop through all of our components. Okay, so that is the next step now for adding our components. So let's go ahead and do add component. And we need to take in some sort of component here. Now, this is where we sort of have an interesting decision to make with our interface here. So for add component, for instance, we might want to take in the component type here. So go about the type and then the actual component here, which would be the I component here. And I'm just going to call that C. And we could have this as our interface. Now, this is a little bit, I don't like this too much because then the user has to sort of look at the documentation, figure out what the component type is by looking at this enum here, and then they have to make sure that this matches. So I don't really like that. I don't want to leave room for errors there, so to speak. So what I'm going to go ahead and do here for my add component is just get rid of this. We'll just add the component. And then if I open this up here, what I'm basically going to want to do here is, again, as part of my interface here, create another virtual function here. And I want it to return the component type. Okay, so must be implemented. Okay, so like we talked about virtual void functions, right? We need to return the component type here. Okay, and let's call this get type here or something. Okay, so that'll be the function type, and here's the return type. Okay, so now we can see that that'll be enforced here with the errors because we have yet to implement component type. So let's go ahead and do that here. And again, these are just going to be quick one-liners here, but the component type, get type, and this is just simply going to return component type texture. Okay, and we're basically going to do the same thing for the collision component. I'm going to go ahead and put in collision. And let's go ahead and do the same thing for the position. Oops. Let's go ahead and do this here. There we are. And now this should start compiling. Let's see what I did here. Oops. All right. All right, let me just clear that. Compile, and it's compiling. Okay, so hopefully that makes sense. Let's go ahead and leave one of these open here, just so again you can see all the code here. And now for our add component, again, where are we adding this? Well, we're adding this to our map here. Now, if this already exists, then it'll be overwritten. Again, I'm making this decision to just have one component. So I'm going to get from our component that we pass in here, just call get type. So that way it'll associate it in the right one spot in the map. And then I'll just assign that here to the component here. Now, here's the other thing we need to think about. Again, if we're using modern C++, you need to think about if you want your components to be shared. Sometimes that could make sense. We probably want this to be maybe a unique pointer for the component types, right? And this could be a map of the unique components. That's probably what makes sense. And then we would just pass in a unique pointer, but we need to move it. Okay, so you need to use move semantics. Again, I'm just going to keep to regular pointers because they're a little bit easier to work with for the purpose of what we're doing here and just demonstrating this concept of a component pattern. But I'll go ahead and just leave it as a note here. May consider using unique pointer for components. Okay, it's probably the right thing to do to not be sharing these or using shared components. As I think about this, usually you want a unique component, at least in a gaming context. I would need to think about pretty hard if we'd want, you know, some objects to be shared. Now that might just also depend on the component type. So for instance, you might have certain game objects that share textures, for instance, but things like positions you wouldn't share. So your options are to either have two maps for the different component types if you think there might be some sharing or not sharing, or just have the raw pointers and just kind of, you know, deal with them or track the ownership and actually look up the components every time you access them from some sort of resource manager that will, you know, sort of own things. Again, those are some design decisions that you can make here. So anyways, let's go ahead and try with this much here. Let's have, after we create our Mario character, let's go ahead and add a component here. And we will add in this texture component, okay? TC here. And I'm just going to pass in the address. Again, I'm stack allocating all these. Again, it doesn't matter if we're on the heap or whatever. But that is yet another design decision. You know, and that's the reason why when I say, you know, you're using unique pointer, because then it's very clear that the game object and the destructor would clean up all the components, versus here, it's not as clear who's responsible for cleaning up those components. So again, some design decisions that you need to think about for the purposes of just getting things up and running. You know, this is going to be fine here, but again, you know, those are the kind of nice things when we think about them. The ownership of memory, we can eliminate some classes of memory errors here. Okay. So anyways, let's compile and run this. So compiling and running. And just to make it a little bit more interesting, we should probably in our updates do like texture, you know, component update or something. Let's just do that just to print out, you know, something. And let's open this up here. Let's replace all these here. Oops. Okay, there we are. And let's print out the right thing here, position, just because we want to give ourselves a little way to debug this to make sure that it's working. Okay, just so you can see what's happening. So if I run this, you can see that we added the component to Mario and we're getting one printout here. There we go. Which is, here, let me go ahead and hide this. Exactly what we're doing, creating our game object, creating a component, adding it, and then updating it. Okay, Great. Okay, now inevitably, the last part that we need to do here is actually to retrieve our component here. So we need basically a get component here. Get component. And which component do we want? Well, we need to access what's in our map here. So that's going to be the component type. So you can just put in the type here. And the return value is going to be, well, it's going to be whatever the component is. So we have a few decisions that we can make here. So for instance, we could just return the I component here. And let's go ahead and see if we're able to do this here. And basically, we need to search for the component in our map. So I'm going to do some sort of auto, just to see if we found a component, and do find here for our type. So we're going to look in our map here. And we'll say if found is not equal to the end. So meaning we found, because again, this is just going to point to some iterator where we find the first instance of our type. And in a map, we just have one here. So if we don't run to the end here, then we'll return the component here, the iterator, I guess, to the component here. Let's see. So this is going to give us the pair or a key and a value. That's what found is pointing to. So I need to look at the second thing here. Okay, otherwise I could just return like a null pointer here. So let's go ahead and see if this works. This does work here and would be fine. Let's see how the interface works here. Let's say if we want to get the component here, retrieve, component equals, so this is on Mario, get component, and then the component type here, the texture component. Okay, so that's going to be component type, texture, okay, something like that. Let's get it all on one line here. And let's try to compile it. Let's see, what have I done here? Oh, missing semicolon. There we go. And this appears to work here, okay? And we could actually on retrieve component here, let's actually just call update on it explicitly to see if it works. Oops, and this is returning a pointer, sorry. So let's make sure that it does the right thing. And I think this is gonna do the trick here. Okay, so that way we can grab the individual components. Now, the purpose for why we might want to do this, right? This might be actually within like our game object class or something, or if you have a scripting language that you attach, right? As we're building sort of an engine here, you might do this in a gaming context, right? You're going to need to retrieve components and then access their properties and those sorts of things. You can certainly do that. So no problem there. And overall, this seems to be working relatively fine here. Now, the example that I showed on the slide here, let's see if I have it here. I did template these get components and add components here, which you could consider doing. You could even consider like special casing these and casting them to make sure that you have the right value and so on. But the main thing is just making sure that, for instance, in our code, if you template them, right, when I have this auto here, let's see if I can break this here. Let's see if I can do like position component and do a pointer here. Let's see if that works here. Okay, so this doesn't work. This is an invalid conversion here. So we are getting an error here. Let's say if I do texture component. Okay. And then I'm going to invalid conversion from, I component to the texture component here. Because again, I mean, if I look at the signature here, it's always expecting this here. So if you wanted to template, that's a way to make sure that you have that concrete type here. Just, I think this approach will work fine here. I templated mine to, again, have some efforts of removing some indirection here in my code and just, knowing exactly what the component type is. I mean, as we saw here, when I call this, it'll still work here. So that seems to be fine here. So anyways, let's go ahead and add the rest of our components to Mario here. So I'm just going to call this position component. And what else do we have? Collision component. So I'll just call that CC. And let's go ahead and just add these here. Again, another reason to think about the ownership model is, so add our components. You don't want to accidentally add the same component twice. So again, there's reasons to probably make these all unique pointers here. So anyways, what we should see here is we've created our game object here, which is like our base class here. and which holds all the components, right? That's in the map, one of each, which I have created here. We add them manually. Again, you can think about doing this in a constructor, or if you have other patterns like a prototype pattern or something, you could just instantiate variations of Mario from that, which would be kind of neat here. We have an example of retrieving a component and then updating it manually or performing any operations and then just updating all of them. So I'm expecting to see one texture update printed and then a texture update again, position update component, and then the collision component updated as well. So let's see if we get that. If I compile and run, that is exactly what we get here. Things seem to be working just fine, which is great. And really, that's it. That's all there is to the component pattern at the simplest level here. Just having some way to hold components within some sort of base class here, and then you can construct the behavior as needed. Now, again, there's usually some sort of like update function that'll call all the components or iterate through it. So that's what you want to enforce in your interface here for your components. And then all of your component classes are derived from iComponent. And typically, if you're going to use something like a map here, you could have some sort of a enum class here. And that's why we added the get type here, again, just to make that relatively trivial to add things to the map. So with that said, folks, that's all there is to it, to the component pattern. Quite nice here, if I must say so. And it's a really nice way to use composition, avoid instantiating lots of different objects, and again, making it very dynamic for adding and removing components at runtime for your objects. So if you missed the previous parts, you can check out courses.msha.io here, my software design series. You can check those out and any more that I'm going to add here. But tell me your thoughts. Let me know what you think about that implementation, how you might improve it, how you might go to an entity component system, which is sort of related to this component pattern. Stay tuned. We'll talk about that a little bit here. But anyways, I hope that was useful to see an implementation and give you a few things to think about. Where I would push this further is to think about unique pointers, think about ownership, and maybe combining this with resource managers, which we've talked about a little bit on this series. If you have like a singleton for a resource manager, or otherwise just creating some sort of holding class, and that could be something like a flyweight, which we talked about if you want to share objects. So again, check out that previous or those previous videos on this series. Anyways, folks, thanks as always for your time and attention. I'll look forward to your comments and look forward to seeing you in the next one.